Well, hello everybody. Welcome to Master the NEC's podcast. Today we're going to talk about some of the changes that are going to take place for the 2017 National Electrical Code. I want to thank you all for joining me today here on our podcast. Also remind you by going to the website masterthenec.com, .net, or .org. You can also watch our webinars and our video casts on our YouTube channel, but you can get there through our website, and you can watch some recent shows we did on the 2014 NEC, as well as 680 for pools, spas, hydromassage bathtubs, hydrotherapy tubs, fountains, and permanently installed pools, storable pool, all that good stuff in a 7-part series back on 680 that you can listen to or actually can watch. So it kind of goes into detail of the change, some of the issues that are important to 680 for those that are interested in swimming pool applications. So that is great for you all that need that. So I encourage you to go back to the website. Again, I'm also going to encourage you to go to our message board, because on our message board you're able to interact with other people on the board. It's a small board, just getting started. I encourage you to spread it around. It's simply, I can promise you there will be absolutely no bashing on that board. I can promise you. If it is, it will be moderated. However, you are able to speak your mind and give your opinions. So, feel free to do so. Just don't belittle anybody, berate anybody. And again, everybody's level of knowledge is different, so respect that, and everything will be good. So there's a website for you to do that. Again, masterthenec.com. You can also catch us on Twitter at MasterTheNEC. We do have a Facebook page as well. Go to Facebook account and search for it. Just search for Master the NEC. You'll find it. And feel free to contribute there as well. All right, so let's get started. So what we're going to talk about today is just going to go over some changes and talk a little bit about the 2017 National Electrical Code. Now, I happen to sit on Code Making Panel 5 and Code Making Panel 17. I really didn't have any real interaction with Code Making 5 on this cycle around. But I did as far as 17 goes, and I did towards the second draft meeting. And we were able to get some things changed there that they were inadvertently were going to actually try to get through, and they left out some wiring methods that were been there for years, so we got that all cleared up. Quite a few changes that took place to 680 when it comes to the 2017, and we'll talk about those on a separate podcast or maybe even on a webinar or in a recorded webinar. So kind of for those that want to see the updates that are taking place to 680, it's quite extensive. But there's going to be a lot of changes throughout the NEC, so just kind of cover some briefly, maybe not go too detailed, but kind of give you a idea of what's to come, and maybe that'll help you get ready for the 2017. All right, well, first of all, there was 4,012 public inputs that took place. Obviously, a lot of activity in this 2017 code cycle. They were submitted to NFPA. And these were recommended changes that were going to take place between the 14 and the 17 NEC. And it resulted in 1,235 first revision results. Okay, so we had the public input, then you had the first draft meeting, and then you had a lot of first revisions that took place there. Ultimately, out of that activity, you ended up with 1,513 public comments that were submitted for the second draft hearing. Were part of, and ended up with additional 559 second revisions, SRs, were actually produced based on those public comments, based on the actions at the second draft meeting. Part of this, there were 9 articles proposed and 5 new articles appear in the 2017 NEC. So be aware that we have quite a few new articles that are taking place, and we probably won't go into each one of those in extreme detail. We'll have separate podcasts for each one of those, but we will discuss them briefly to let you know what changes they are. So quite a few changes took place here in the 2017. I know the people out there who say, why do we have to keep changing it? Well, it's an ongoing effort to make the document better, easier to understand, a better overall document to enforce, and it's just it's a constant process in order to make it better. All right, I guess the first thing we want to jump into is, what are the 5 new articles that are going to take place? So for you out there who are thinking, what are these 5 new articles that might impact me? Well, the first one is going to be Article 425, and that is fire resistance and electrode industrial process heating equipment. Okay, so if you're dealing with any of those fixed resistance and electrode industrial process heating equipment, and that is part of your bailiwick in your industry, then good news for you. Article 425 is now going to be in the National Electrical Code. The next one is going to be Article 691, which is going to be in here, and that is for large-scale photovoltaic PV electrical system station or electrical supply stations. Okay, so large-scale photovoltaic electrical supply stations. Obviously, it's not the same as our 690 dealing with our normal photovoltaic applications, which are going to be limited to a certain scale. Here you got some large-scale applications, and you're going to get some kind of guidance for there. That was extensive work that was done by those folks who look at 690, like Bill Brooks and all those individuals, Jim Moore, all those people who looked at it and gave it a lot of thought. And no doubt they pulled a lot of information from 690 and in other aspects of the code, 480 batteries, and I'm sure they pulled a lot of that information from there. The next article that you're going to have to be aware of is they're going to be the energy storage systems, or ESS, and they're going to interact a lot with 480, which is batteries. Energy storage systems can be a multitude of types of energy storage systems. It's going to interact with 705 as well for interconnected systems, but it's all going to be working in relation, and 706 is something that you're going to have to contend with when you're getting into energy storage systems. Okay. And again, a future podcast or a webinar will probably go over each one of these articles in depth, and we might touch on a little bit of each one of them today. Article 710, Standalone Systems. So any system that we have that is a standalone type system, you're going to see it incorporated into 710, which you're going to see that other things like 706 or whatever is going to integrate and work well with 710. And then another article in 712 was brought into the code, and that is direct currents microgrids. A lot of debate at the NITMAMs and a lot of the training episodes that took place during it really started to have a confusion with the microgrids. And I'll be honest with you, on the NITMAM there was a lot of argument over the utility industries pushback to the use of microgrids. They kind of think that's a utility term. And they really don't want to deal with it. This is kind of like your direct current standalone contributing systems that can contribute to the grid. But there's no real clear understanding of what a microgrid is. It could be 2 little panels, or it could be 1,000 panels. It really didn't have a definition for it. Now, I will grant it, there were quite a few changes that were submitted to the NITMAMs. And I have to be honest with you, once I got past the issues that I was dealing with, I kind of zoned out when it comes to the changes, because there was quite a few that were put forth here at the end and quite a bit of debate on it. And so, I'll be honest with you, I can't tell you the outcome of all of those NITMAMs when it came to the microgrid, but I'm going to go venture to say that they probably kept the microgrid language in there. There was a strong argument against removing it. So we'll update that. As always, I do podcasts to try to keep you updated. So if you're in that industry and you're dealing with these direct current microgrids, small independent grid systems, if that's what the intent is, then we'll get you some more information as we find out more about the code changes for that. And we might talk a little bit about that if we get to it today. And we're certainly going to define it for you, because I think it's important you understand what each one of these articles are actually going to say as far as the language. So let's look at each one of them, and kind of I'll read it to you, and you kind of understand how they're going to work, and you have to determine whether or not they're going to affect you. All right. So Article 425 is called Fixed Resistance and Electrode Industrial Process Heating Equipment, and here's what it's going to cover. Here's the scope. It says this article covers fixed industrial process heating employing electric resistance. Okay, so it's industrial process heating, employing electric resistance or electrode heating technology. In other words, boilers, electrode boilers, duct heaters, strip heaters, immersion heaters, process air heaters, or other approved fixed electrical equipment used for industrial process heating. That's what this article is going to cover. So if you're dealing in the industrial industry and you're dealing with this employing electric resistance or electrode heating technology, and it incorporates all those items that I talked about, then it's going to affect. This is just going to be one more article that's going to give you some guidance. That's the key. Article 691, we talked about it. That's going to be a new large-scale photovoltaic PV electric supply station. Now, what is this article going to deal with? This article is going to cover the installation of large-scale PV electric supply stations operating for the sole purpose, okay, the sole purpose of providing electric supply to a system operated by a regulated utility for the transfer of electrical energy with the generating capacity of no less than 5,000 kilowatts. Basically, this is going to cover generating stations, substation, associated generator, storage, battery, transformer, and switchgear areas that are associated with the regulated utility aspect of it. Again, a lot of people will argue why bring that into the code, because it's kind of on the utility aspect of it, and it's really outside the scope of the NEC. But I think that as this evolves, you're going to see what they're talking about for it. Article 706, Energy Storage Systems. Okay, new article. Scope is this. This article applies to all permanently installed energy storage systems operating at over 50 volts AC or 60 volts DC that may be standalone or interactive with other electric power production sources. So this is huge, because you'll have those systems that are under 50 volts, and they're still going to be the some old legacy battery systems, for example, that actually work at 48 volts aren't going to be covered here. There's lead acid type battery systems, but most of your other ones are going to operate at over 50 volts. So you do have some legacy ones that are going to fall outside of this, although they're still going to have to meet the requirements of 680 for batteries. That's not changing. You're just going to see a more interactive energy storage system requirements that are found in 706. And obviously, due to these voltages we're talking about, it's going to have to interact with 480. It's going to have to interact with 705. It's going to have to interact with 710, 712, all of those aspects of it. So, maybe that's that guidance we need for energy storage systems. As you know what, these photovoltaic systems and all these other energy producing systems, as we want to use them more, we need to focus on how we're going to use this energy and how we're going to store this energy. Because if you can't store the energy, then unless you're just trying to be green, it's useless. So we need to produce some work out of this. So energy storage system, having some requirements in 706 are good. Oh, incidentally, a shout out to Jack Lyons with NEMA, who did a presentation on ESS systems at the NFPA convention or conference, I guess, for the NITMAMs, and he did a great job. Kind of gave an overview of where we're going. Didn't really get into describing them in detail, except for giving a broad overview, which is really all that was necessary for that type of class. So, but I think Jack did a wonderful job. Excellent presentation. Does NEMA proud, as all the reps do NEMA proud. Did a great job. So you missed it. If you weren't there, you didn't get to learn about energy storage systems, but I'm sure you will more as we go on further. All right, so next article was Article 710. So you're thinking to yourself, how does it impact me? Well, it's standalone systems. This article covers electric power production sources operating in standalone mode. Okay, so any electrical power production source, whatever it is, if it's operating in a standalone mode or has the ability to operate in a standalone mode, then it's going to have to also meet 710, which is a standalone system. Okay, so we have some guidance on the standalone systems. All right, Article 712, direct current microgrids. And of course, in parentheses, it's going to have DC microgrids. Again, arguments by the utility is that, we really don't need the NEC using the term microgrid. Again, I don't know how that turned out. I have to wait for the results of the NITMAM to come out. I know they're not ready yet because we're still sending in some additional ballots on some of the changes here. But anyway, we'll keep it posted. So what is it dealing with? It says this article applies to direct current microgrids. All right, we don't really know what it is. What is a grid? Is it 2 arrays, or is it 1,000 arrays? Is it, what is it? Does a 2-grid system on my house qualify as a microgrid? I don't know yet. But anyway, it says this article applies to direct current microgrids, which is a power distribution system consisting of more than one interconnected DC power source. Okay, so I guess that could be 2 panels, right? 2 arrays. Supplying DC-DC converters DC loads and or AC loads powered by DC to AC inverters. Okay, so sure does sound to me like it might be just about any system out there. So maybe there is an argument why the utilities are like, hey, leave the microgrid words out of it. I don't know. We'll let them argue that out. And again, I don't know how that came about. So it's real important also that I guess we go into you understanding how this works. So once all these things are submitted and they go from the second draft and everything gets submitted for this 2017, then it goes to correlating committees, which what they do is they resolve conflicts, establish correlation between any of the other NEC documents. They ensure that the NFPA regulations and the style manuals are followed, all this kind of thing. They make sure all the rules of the code panels were followed and done correctly. And then, of course, their job is to identify technical errors and determine how we're going to solve those errors. So that's kind of what that group does prior to when we get to these NIPMAM type of scenarios. Now, so that's kind of what they do. They also assign task groups who look at individual items that are being presented. And these have, there are 5 assigned standing correlating committee task groups. Each has a chair and each has a specific function. The chair reports the completed work of that task group, and they do it to the correlating committee, and they send it to them, and then the correlating committee looks at it and has to accept it. And all correlating committee FRs and SRs are voted on and moved by consensus. And then that's what brings us to the point where you then get to a NIPMAM application issue. Now, what are the task groups? Well, there's Code Making Panel 7, Code Making Panel 8, Code Making Panel 14. Task groups are coordinating wiring methods used in hazardous classified locations. So those are the ones that are meeting together to discuss hazard classified applications. At Code Making Panel 4 and 5, they coordinate requirements related to grounding and bonding, triggered by new terms such as functional ground or reference ground or any type of term that we want to have clarity on. They will look at it and make sure that it's meeting the application that it needs to be and terminology-wise. Now, all right, and let's see. Standby power system task groups to work on consistency between the requirements and multiple electrical standards. They actually look at the NEC, and then they kind of look at other NFPA standards, like with generators and standby power systems. They're going to look at NFPA 110, 111, other documents, some cases 90, different ones, to try to correlate. That's what they're going to do. So the task groups look at that, and then they try to bring that all together so they can bring it back to the correlating committee. Okay. Now, let's talk about global changes, some of the global changes that were put in there, and it's still in the work in progress, but several public inputs and comments added the words like, quote, and labeled after the word listed throughout the NEC. So this was a broad change. A lot of this was submitted by an individual with UL, I know very well, respect very well, good friend of mine. And he submitted this in, and it went in during the second draft stage. It got in, and then, of course, once it got in, some committees accepted the revisions and the comments, and some did not. Some of them didn't like it. The problem is, what happened is that you had some of them require that and labeled after listed, and some did not. So it created a code where some required the language and then some didn't, so it became very inconsistent, and there was problems with it. So again, that's a burden that the correlating committee has to deal with. And because of that, they deleted all of the applications where you put and labeled after listed, and then returned it back to the 2014 language. So that's a kind of an example what the correlating committee will actually do. Okay. One thing to remember is that the code making panel designated for technical responsibility will follow definitions in Article 100 and chapter. In code making panel 1 has responsibility for the general definitions such as accessible and insight from and what's readily accessible. They're responsible for those in code making panel 1. Okay, that's their responsibility. That's under their purview. All right, and let's see here. Let's go on and get into some of the changes that took place. Most notably, we want to start off in Article 90. Okay, the words "and removal" have been added to the first sentence of 90.2a. It kind of expands the scope of the NEC beyond just the installation requirements. It includes requirements for addressing the removal of certain types of equipment. Very similar to what we see when you talk about removal of abandoned communication cables. So currently the NEC rules require removal of equipment such as those for removal of temporary power, for example. You use it, when you're done you have to remove it. You don't exceed 90 days, and you use it, you do what you got to do, and you take it out. Well, throughout the code it seemed that 90.2a didn't really address that application, so it expands it to make sure it doesn't understand it. It just doesn't apply to the scope of just new equipment or what's covered. It also covers the removal of specific types of installations too. So it's important to add that in what is covered. Okay. Now, when you're dealing with what's not covered, energy storage is included within the scope of the NEC. The term energy storage is specifically included in 90.2b, clarifying that energy storage installed and under the exclusive control of the utility is not covered by the NEC. So remember, any of those aspects of energy storage, and we talk about ESS later, you have to remember that if it is under the exclusive control of the NEC, it might be covered under the NESC, National Electrical Safety Code, or other regulation that the utility might use. But if it's under their control, it means it's theirs, it's for their intent. Maybe it's their intent to give back to the grid, their intent to supplement the grid, offset. Again, if it's under their exclusive control, then they're outside the scope, and the NEC doesn't cover that. So it's important when we start looking at energy storage systems and their use and how they apply, local uses and buildings and things like that, trying to separate the fact that it's important to understand what's not covered by the NEC. Okay. All right, so the next thing we're going to move into is, let's see here, I'm going through the documents that we have for the NEC changes. And let's look at 90.3 code arrangement. One of the things that we want to remind everybody that the general rule for people to understand is just chapters 1 through 4 of the National Electrical Code apply generally through all applications. Now, you do have 5, 6, and 7 which apply to special occupancies, special equipment, other special conditions, and they may supplement or modify the general requirements in chapters 1 through 4. I guess the notion previously was that they really are there to supplement or modify chapters 1 through 4 only. But the reality is they can modify chapters 1 through 7. Remembering that chapter 8 is a standalone, it can make reference back to certain things like 300.4 for protection through bored holes and whatnot, joists and studs and whatnot. They're making a reference directly back. The reality is that 5, 6, and 7 can modify or supplement any of the chapters 1 through 7, even their own counterparts in 5 and 6 of those 3 chapters. So I think the implication before was that it really was pushed back to modify chapters 1 through 4, and 5, 6, and 7 were kind of their own islands, and they can't modify anything that might be covered in 5 and 6. But the reality is you have special occupancy, which is in chapter 5, which special equipment could apply to a special occupancy or vice versa. So, we have to remember that they have to work seamlessly between each other. So I don't know that was the result of what they wanted, but that's the intent of the change, to allow it to be able to modify and supplement any of them through chapters 1 through 4. 1 through 7. Also remembering that 1 through 4 is also the general rule, so it applies throughout all of the chapters except for 8, which is standalone unless it's referenced back, like we said. Okay, so just adds clarity that 5, 6, and 7, yes, it does modify chapters 1 through 4, but it can also modify 5, 6, and 7 as well. All right, so let's look at 90.7, examination of equipment for safety. A new last sentence was added to the second paragraph of 90.7. Basically, the words that were added were that are compatible with the code have been added to informational note number 3. Okay, so that has been added. The revision clarifies that the suitability of equipment is related to application of requirements and standards that are consistent with the NEC rules. Okay. 90.7 examination of equipment for safety. Examination of equipment for safety for specific, for example, as in the 2014 NEC with the last sentence that was added, suitability shall be determined by application of requirements that are compatible with this code. Again, the informational note reads as this to 90.7. It says, Informative Annex A contains an informative list of product safety standards for electrical equipment that are compatible with this code. Okay, so it actually tries to address you and tell you that you have some standards that are listed back here in Informative Annex A, and they are compatible with this relevant code, which is NFPA 70. All right, let's go into Chapter 1 and get out of these 90s here. Chapter 1, we have some relocations of some definitions. Okay, so we know the understanding that definitions are whereas you have it in more than one article in the code, then they got to be relocated back to Chapter 1, most notably Article 100 for definitions. Okay, so multiple definitions previously located in 500.2, which would be conceivably specific to hazardous locations, are obviously used in other areas of the code now. So what you have is now you have it being relocated to 100, many of those definitions, because they are used in more than one article. They're used in more than just 500. Okay, so that's expanded out. Section 2221 of the NEC Style Manual requires that if a term appears in more than two articles, actually I think if it appears in 2 or more articles, it shall be included in Article 100. Okay. The words, quote, as applied to hazardous classified locations have been added following each relocated defined term, but it's actually before the definition. So it's kind of between the word and the definition. It's right there to let you know what it applies to. So this word that they give you, which was previously in 500.2 for hazardous location, they still want to make sure you know the intent of where it's going to use. So throughout the code, they're starting to put these parentheses right between the definition and the actual word in order to kind of say, hey, this is where it applies. Like readily accessible applies to the equipment or to the location type of thing. It kind of gives you that direction on how am I applying this hazardous location, and that's what it does. So it's kind of giving you a little guidance. It's probably a good move. I like more of that direction. It's kind of like a fine print note or now an informational note, but it's kind of stuck in there in the definition to kind of give you some guidance. Hey, this definition applies to this area of the National Electrical Code. Kind of, gives you some direction now. The definition of the term readily accessible has been revised. All right, the definition maintains most of its existing text, but now includes the words other than keys. So a lot of people argued that something wasn't considered readily accessible if you had to get to it by key. Now, obviously, it's readily accessible to those that need ready access, but there was a big argument that the key doesn't make it readily accessible. So they made the intent to say, look, you can have it locked by a key and it's still considered readily accessible. Prior to that, people argued that if it was locked by key, it wasn't readily accessible. So this is just cleaning up some language for the intent. A new informational note has been added to address the common practice of use of keys and gaining accessibility under control conditions. So you have keys and it's locked, and you can still, those that need to get access to it have access to it. Those type of things. So it's just kind of adding language to it where people in the past have said, well, I don't know that if it's got a key and it's locked, if it's technically readily accessible. Even if there's somebody on site that has ready access, who's required to have ready access, but maybe possibly they don't have a key because the other person that works a day shift, for example, forgot to leave the key or something. So I think it's, you can't fix that with this language, obviously, but I think that it's just trying to say, hey, it's still considered readily accessible even if it's behind a key. And here's what the code says. It says readily accessible, and then of course readily accessible, capable of being reached quickly for operation, renewal, or inspection, without requiring those whom ready access is a requisite to take actions such as to use tools other than keys, to climb over or under, remove obstacles, or to resort to portable ladders and so forth. Okay, so you don't want to use keys saying it's locked as not meeting the readily accessible application. Okay, that was never the intent, and I think they made it clear here. And a lot of panels that are required to be readily accessible are locked by keys. Okay, they have a key lock in them. So this is just bringing clarity. All right, so let's get into the next one here. We're looking at, bear with me, my slides, everything moves kind of slow here. Okay, Article 100, building. The words, quote, with all openings therein protected by approved fire doors, and, quote, cut off, have been removed from this definition. So through the process, we really didn't know what the word cutoff was. We know what the separation in the building when you have a firewall. And when you have a firewall, it implies that you have two separate buildings. So if I have a building that's separated by a firewall, then I have two separate buildings, okay, provided you meet the requirements in the building code for what constitutes a firewall. So the term firewall already implies that any openings such as windows, doors would require to be fire rated. So in a firewall, you have very limited applications where you could even penetrate a firewall. And even if you did under the building codes, then you have to the actual penetrations have to meet certain requirements anyway. Okay. The best rule of thumb is do not penetrate a firewall. Okay. But you will have applications where you will have fire doors, you will have something that actually will be in there, it will be rated for such application, and if it is, it's just needed some clarity to the definition for building when it comes to Article 100. So they just removed with all openings there protected by approved fire doors and cutoff, which, again, the fire doors part's fine, but what you have is separated replaces the word cutoff. So the actual language will be this when it comes to a building, which, again, here's some good news. We're going to have a definition of building and a definition of structure, because a lot of times people think they're synonymous. And yes, a building can be a structure, but we also have to understand that some isolated equipment is being designated by many people as a structure requiring grounding electrode system, and they aren't really required because it's just a piece of equipment. So we have some definitions, brings clarity to the application. So the new language for building is going to be this. And it harmonizes with the 2014 and just kind of made these changes. Got rid of that term cutoff. It says a structure that stands alone or that is separated from adjoining structures by firewalls. Well, that makes sense to me. So that was a good move. That's good editorial change when it comes to what a definition of a building is. And then a structure is that which is built or constructed, comma, other than equipment. So it's very important that we distinguish equipment, listed equipment, all these type of things in order to be able to classify them away from being a structure. I put an isolated motor for some reason. In the past, people would say, hey, that's a structure. And I'm like, well, it's not a structure. It's a piece of equipment. Okay? So kind of brings clarity, gets rid of some of that confusion of what a building and structure is. You know, we started understanding it a little better in the 14, and here we're just making it a lot clearer. So how's it going to read? The building, it's going to be building a structure that stands alone or that is separated from adjoining structures by firewalls. And that was done by Code Making Panel 1. And also, a lot of times now in the definitions, you're actually going to see the actual code making panel that is responsible for that change added to a lot of the areas in the code so that you can actually see which code making panel is the purview is for them to make that change. Okay. Welcome change there. Code Making Panel 1 did a great job on that. Two NEMA reps sit on the Code Making Panel 1, Mike Stone and Don Iverson. They do a great job, and I'm sure they had a hand in that on behalf of the manufacturers as well for clarity. All right, Article 100, cord connector, a new definition of cord connector, and then again it gets into brackets and says, as applies to hazardous classified locations. Remember we talked about it? It's going to say, look, this definition is applying to hazardous classified location, has been added to Article 100. So see how that works? You get a definition and you get to see where it applies to, if it's specific to a certain application. This term was previously undefined, yet appeared in multiple areas of the NEC. Obviously, we needed a definition. So that's where we're at with that location. There's no current definition for the term cord connectors appearing in NEC chapters 1 through 4. So, all right, so we needed that application to add it into the NEC. So currently there is none. Dust tight definition. The definition of dust tight and associated informational notes previously located in 500.2 and 506.2 have been deleted. The existing definition of dust type in Article 100 actually was revised. So we had two different definitions going on, and so they revised the one in Article 100, and they did so to incorporate and contain the concepts contained in the previous 500.2 and 500.6.2 information. Simply, you're talking about microns and all this. That was all pulled over into Article 100 where it probably should be. Okay, and this all meets the applications of the NEC Style Manual in Section 2221 of the Style Manual. And now the definition is actually going to read, and again it's going to give you the code panel that's associated with this, and that's Code Making Panel 14, is dust tight. Enclosures constructed so that dust will not enter under specific test conditions. And of course you'll have two informational notes that are under that as well that you can use. All right, so my field evaluation friends out there, the ones ETI, Vince Delacroce, all these guys I know that do what's called field evaluation testing, you have two new definitions for them that kind of going to help, put in there what this means. And it's definitions of the term field evaluating body, or FEB is the acronym for that, or field labeled, have been incorporated into Article 100. All right, so the NEC Style Manual indicates that terms appearing in more than two, I actually think I have to look, but I think it says those that appear in two or more qualify for definition Article 100. It says these definitions have been developed from concepts derived from the terms of NFPA 790, which is the body of 790 and 791 are the body that a lot of these field evaluating bodies use in order to do field evaluations and things like that for compliance and what have you. Componentry come together and you have to have a field evaluation, and they do these field evaluations. And these field evaluations ensure that it's listed, it is equal to or the equivalent with the standard to which it would be constructed if it was done through manufacturing. They'll look at it and do an evaluation on it, and they'll be able to put a stamp on it for specific use. That might be a real good example of that. It might be a piece of equipment that's coming in from Europe and it wants to be used here. The components might be made up of ULRU or backwards RU type of recognized components that have been evaluated, and they bring them together in a piece of equipment that hasn't been evaluated, and then they'll call a field evaluating body out there who will come out there, do the evaluation, and they will field label that product, and then usually the AHJ is acceptable to that product. Okay, so it's a welcome addition of some terms that brings some value to this field evaluating body as well as their field labeling programs, and they serve a vital role in our industry. So I think that's a good move to finally get some definitions in there. And I will read you the definitions that are going to be in there from the FEB, which is a field evaluating body. It says an organization or part of an organization that performs field evaluations of electrical or other equipment. And again, it's derived, and it'll tell you that it's derived from NFPA 790. And then you have field labeled, and then they'll say in here, in parentheses again, remember it's going to help give you some guidance now. It says, as applied to evaluated products, okay, products that are evaluated in the field. That's the whole intent here. It says equipment or materials to which has been attached a label, symbol, or other identifying mark of an FEB, which again is Field Evaluating Body, indicating the equipment or materials were evaluated and found to comply with the requirements as described in the accompanying field evaluation report. Okay, so that's what they're doing, and they field label it, meet all the requirements that they're required based on the standard they're evaluating to and their specifications within their test body themselves. Then they apply a label, and that's called a field labeled, as it applies to the evaluated product. Okay. In the definition of field evaluating body, it's an organization that's part of an organization that performs field evaluations on equipment, on electrical or other equipment, again, within NFPA 790. And again, it's under the purview of Code Making Panel 1 because it's in Article 100. And we already read the field labeled, so we're good on that one. Next, we have a definition change for receptacle. I don't know how many times we're going to change this, but it makes sense because when people start migrating away from a receptacle and think that they're just talking about a duplex receptacle, which is just two single receptacles, or a simplex or single receptacle, which is one receptacle, but you have other types of receptacles that are out there. So here's the definition change of what a receptacle is. It's a contact device installed at an outlet. So remember, you can have a bunch of different types of outlets, receptacle outlet, lighting outlet, whatever. It says for the connection of an attachment plug, so appliance has a plug on it, that's an attachment plug. But it goes on to say or, and this is the new part, or for the direct connection of electrical utilization equipment designed to mate with the corresponding contact device. All right, so now we have these new devices, and they actually introduced these to us while we were sitting in Code Making Panel 17. And they did a great job. Amy Cronin, who represented that for the inventor of the product, got it in the code. It just simply made sense. It's a new type of receptacle. It's designed to work and mate for ceiling fans, large heavy lighting fixture, different things like that. It actually mates A to B, and they click together, and they securely hold the product in place. So you have these applications where you might have some type of utilization equipment that is designed with a mating system, and it has a corresponding yoke type of contact device, and these things come together, and that is also considered a receptacle. So look for those out on the market. You're going to start seeing these incorporated in things like ceiling fans and other aspects. Okay. It goes on to say, and this is not new language, but it goes on to say a single receptacle is a single contact device with no other contact devices on the same yoke. Okay, that's important because if I have a duplex, that's two receptacles, right, on a single yoke or same yoke. A multiple receptacle is two or more contact devices on the same yoke. Obviously, that's a duplex. Okay, so just kind of giving you some clarity. We're all probably pretty familiar with that, but you have these new devices that are out there. And basically, there's an A and a B, or a male and a female end, and they're designed to integrate together and hold whatever object they're designed to hold, and that is still considered a receptacle. Article 100, structure. We did cover this earlier, but this clarifies that equipment is not a structure. But you could mount this equipment on something that would be considered a structure. It's just you have to understand that the equipment doesn't define the structure. The structure to which it's mounted on possibly might define the structure. Okay? So what is the definition of structure again? Is that which is built or constructed other than equipment. Again, under the purview of Code Making Panel 1. Okay? In other words, I could build a tower that holds raceways, right? And basically the structure is the structure that's supporting the raceways. But the raceways are equipment, and they're not the defining term whether or not of what is considered a structure. Okay, just kind of keeping those two things in mind. A good example of that. Well, no, I'll skip that. We don't want to go there. All right. Skip over substation. I don't want to talk about that. There is a new definition of substation that's in 100 that you need to look at if that's what you deal with. I'm not going to get into that one. Listed, 110.3c, listed. The title of 110.3 has been revised to include listing. That's product certification. So a new subdivision C and associated information or note have been added to 110.3. You know, and this, what it is this revision clarifies that a product certification be performed by a recognized qualified electrical testing laboratory, or NRTL. And it says that, look, OSHA is the one that provides the list for these NERDLs, okay? So the list can constantly go up and down, up and down, and up and down. So in order to give a resource to the actual AHJ, or those that want to make sure something has been recognized and evaluated by a NRTL, National Recognized Testing Laboratory, then what they got to do is they'll go to OSHA, and OSHA will give a reference of all of these places, like METS, ETL, UL, a bunch of different FM. All of them are equivalent. Now, not all of them do the same testing on the same products, but in reality, as far as in the accepting world with AHJs, they should accept a ETL Intertech mark just as easy as they accept a UL mark. Just because the UL standards are developed using ANSI and UL and a bunch of others that combine together to create what is called a UL standard, like for wire, THHN, which is a thermoplastic, is under UL 83. But that has no bearing on the reality of when it's tested. You could have it tested and evaluated as long as you construct it to the standard, which originally, to be honest with you, starts out with an ASTM standard for the copper or aluminum in how you develop the conducting property, and then you insulate it, and you meet all these flame testings and all this stuff in accordance with UL and what have you, IEEE for the flame tests, and and then you have the vertical flame and horizontal flame and smoke propagation. You have all these tests, but at the end of the day, all these tests don't have to be done by UL. All these tests can be done by any of the NRTLs that are listed by OSHA. Okay, so that's important, and they're just making clarity here that that's the case. All right. And currently there's quite a few lists that OSHA lists of NRTLs, like, again, UL, TUV, Ryland, CSA, FM approvals, IAPMO, which is basically plumbing and mechanical. Intertech lists theirs, ETL, Met Labs, NSF International. There's a bunch of them, and all of those are governed through OSHA. Okay, and that's all it's basically saying. Hey, look, we don't want to do a list in the code. It could change. These people could drop off if they don't pass their tests and maintain their lab. The list is always changing, so you know what? Let's refer to OSHA, and you can go there and see who's an RTL. All right. 110.14d, installation. A new subdivision D titled Installation has been added following 110.14c. Of course, 110.14c is dealing with terminations, what have you. So the D now is going to throw in some requirements for torquing. Okay, so we always had the requirements to meet the manufacturer specifications in 110.3b. Most all the manufacturers are going to put torque values on their lugs. So that is information that's either on the panel legend or on the side of the lug kit or in their literature or whatever. Now you just have a requirement to say, hey, look, there's mandatory torquing requirements that have to be followed. And you have to install them in accordance with the manufacturer's instructions, which I thought, we pretty much had to do all along anyway. Okay. We also had other guidance that we could go into 486A, B, or we had, was it 486 or 496? I can't remember now. I'm having a blank. Anyway, you get what I'm saying. You had some torquing requirements in the code. Dude, I tell you, I teach so many codes and so many standards that sometimes I just draw the blank, And you know what? Because it's going to drive me crazy, and I know that I've got a plethora, how should I say that? A plethora of haters out there who'll say, why don't you know that, Paul? Whatever. Okay, so I was right. It's 486A-B, which is our torquing requirements. Those are UL standard. And of course, you've got informative Annex I, which pretty much regurgitates that within the NEC. So the only difference here now is that we're going to require it as part of its own separate subsection. And the reality of that is you're going to have to show the electrical inspector that you actually own one, and they're going to require that it's calibrated, that you have one on hand. So really, it doesn't do anything different than what was required before, except for maybe give the inspector a little more teeth to say, because people argue that 110.3b, and they say, well, it doesn't say it directly. Well, sometimes things don't have to say it directly to understand what it means. But now it's pretty clear that you're going to have the torquing in requirement, okay? And of course, that informational note was there that talked about torquing is no longer necessary because now it is actually a requirement. So in the code. So if we were to, let's see if I can find, let me look up the definition if I can find it. Hold on. No, hold on for a second. Don't run off on me yet because I want to read. I have a summary of the changes and I don't see that. Bear with me. Basically, that's just what it says. It's just going to, in that statement in D, titled installation, it's just going to basically say that you have to tighten the torquing requirements for electrical terminations in accordance with the manufacturer's instructions or allow for alternate methods as provided in the instructions. So you either follow the manufacturer's instructions unless they have any alternate instructions. I guess the biggest thing to take away from this for you electricians out there, that where a tightening torque is indicated as a numeric value on equipment or in installation instructions that the manufacturers give you, then you're going to have to use a calibrated torque tool, and it's going to be required to achieve that indicated torque value, and you're going to have to be able to show that value to the inspector. And you'll have to develop how you do that. If you torque it to a certain level, and then you use the device, it should snap or break at that value, and maybe you do that for the inspector, as long as it doesn't continue to torque it, because you don't want to over torque it and damage beyond it. You just want it to break at the proper level. If it's set right, it should break. I think the biggest thing the inspector's going to want is to make sure you got one on site. That's the key. So hopefully you get one. You might already have one. If you should have had one. I had one for years when I was in the electrical industry, and I used to always do a little funny thing when we do SC cable, and they would torque it and they would over torque it, and people had so much concern over aluminum, which is not the case, but they have a tendency to over torque aluminum rather than over torque copper. It's some kind of mentality. They get in and think, oh, I got to make this aluminum tighter because it moves. Again, you can listen to my little thing on aluminum. It's not the same aluminum today as it was back in the late 60s and 70s. You don't have that much difference in movement or creep or temperature, coefficient of temperature adjustment or change or expansion and contraction the same. There's been an argument that when the lugs heat up, it changes and then it contracts back. And look, if you size the lug right, you follow it properly, you torque it right, shouldn't be that big of an issue on it, and it shouldn't be any more of an issue than copper would be, because it also has coefficient of thermal expansion and contraction. So anyway, beyond that stool, I will get off that stool. Just torque it right, make sure you have the right torquing wrench to do it, and you should be good to go. Okay? All right, 110.16B for service equipment. A new B entitled Service Equipment and information note have been added to 110.26. So the provisions in 110.26 now require more installation related detail and information for determining the arc flash energy levels and required PPE. So you've seen this kind of grow, you've seen this expand, the labels that are required. You have the informational note which references NFPA 70E for specific criteria related to an arc flash label and determining appropriate PPE. You've seen all that, but now you're going to see a little bit of a change. Now, here's what the language is going to say. It's going to say in other than dwelling units, okay, so not applying to dwelling units. It says addition to the requirements in A, which is our normal marking requirements, you got a B now. And the B says a permanent label shall be field or factory applied to service equipment rated 1200 amperes or more. Okay, so your 1200, this B is going to kick into other than dwellings and 1200 amperes or more. The label shall meet the requirements in 110.21b and contain the following information: normal system voltage, the available fault current, the clearing time, and you get that from the overcurrent device as far as the trip curves from the manufacturer, and the date the label was actually applied. So you had your general requirements in A, and now you're going to have some specific requirements in B to be added. Okay. Now, the exception here is service equipment labeled shall not be required if the arc flash label is applied in accordance with industry practice. Okay. All right. So on a new label, you've got your boundaries, you've got all these other applications that are required under this 11016. You know, we got to know the incidental energy, the working space, the level of PPE. The only addition to this is now on that label, you're going to have to provide the date this label was applied, because it's important, because changing anything in the system can change that energy when you're dealing with available fault current, when you're dealing with that arc flash incident. Okay. So we're not talking about short circuit current ratings at this point. We're not talking about the available fault current labeling that required. Here we're talking about the label, for example, when it comes to an arc flash warning label. And it needs to have the nominal system voltage. That's the nominal system voltage, okay? 120, 240, 480, those nominals. Available fault current, which you should get through a available fault current study that you're going to have to take place, because you got to do that anyway in the general requirement to label it for available fault current. And then, of course, service overcurrent device clearing time. So you have to find out what the value is, and every overcurrent device, fuse or circuit breaker, has a clearing time, and that's obtainable from the manufacturer or within the specifications for that device. So you got to put it all on here, and that's now going to be required. No guidance on the label other than, you know, it's a typical warning label with the orange background, and it's basically an arc flash and shock hazard label. Okay, this is a 110.16 application. Okay, and of course this label could be in other way. You know, there's all different ways that you can compile this information, but you know, you have to make sure it's on. So the key components that are being added here to what you normally had to do, the key components is the date, the clearing time, you know, probably 3 cycles, for example, the voltage 480, and an available fault current, which you've done through your other study, which might be 35,000 amps, and you know, that type of thing. Of course, already the information you're going to have on there is the PPE, whatever. So don't get this one confused with the available fault current markings and the application of short circuit current rating. This is totally different application here. This is for the protection, and what type of protection under 110.16 is required. All right, and with that said, we have a new provision in 110.21A2 dealing with reconditioned equipment. Okay, so one of the things in reconditioned equipment is the title of subdivision A has been changed from manufacturer's markings to equipment markings. And basically section 110.21A has been renumbered as line items 1, and the new list item 2 is dealing with the new exception and informational note, which the list item 2 provides marking requirements for reconditioned equipment, including the responsible organization and the date of reconditioning. So here's what's going to happen under 110.21A2. When you have a piece of equipment that's reconditioned, okay, it's going to have the statement that it's reconditioned. It's going to have the date of reconditioning that's required on it. It's going to have the company that did the reconditioning. All of that information is going to be on the label, okay? So that the individual knows that it was reconditioned, okay? Now we get into the other 110.24A field markings. A new last sentence has been added to 110.24A addressing calculations. Okay, so now we're getting with this application here, and we're dealing with available fault current. So we've had some additions now to this. When you saw 110.16 with arc flash, now we're getting to available fault current markings. Now, they've added an additional sentence. The additional requirements are to document the actual calculation to make it available to those authorized to design, install, and inspect, maintain, or operate the system. So we have to know how you came up with the math. So the maximum level of available fault current can be readily obtained from published utility data or by use of a calculation method. So I can get this information from the utility if they provide it up to this point, or through a calculation method. So what it actually says is, and I'll just paraphrase it down to the importance of the new part of it. It says service equipment, and then you got your regular existing text, and it says environments involved. It says the calculations shall be documented and made available to those to those authorized to design, install, inspect, maintain, or operate the system. Okay, so in this case now, when you design that available fault current, or you put this value on your label as required by 110.24, you're now going to have to show how you came up with this method. The good news is there's a lot of apps out there on your phone. I think Busman makes one. You punch in all the variables, you punch in what you're given, and it'll be able to give you a document that you can print out, and then you can show, it'll print out the information and show you how you came up with this method. Okay, and it has to be there ready for those that might design a system or change something in the system. Somebody might be inspecting the system, maintenance follow-up. All of those type of things now, you have to provide that information, and it needs to be kept in the system. Okay. All right. So what it's going to result is quite a few labels. If it's remanufactured equipment or reconditioned equipment, got to have a label. The maximum available fault current required, got to have a label. Under 110.24. The arc flash warning information might be provided by the manufacturer, might require some field evaluation. In other words, to come up with the calories, those type of applications, or proper PPE, whatever, that's under 110.16. So you'll have quite a few labels that are going to have to be on equipment. Let's see here. On service equipment. Okay. Let's see here. What else are we looking here? I'm looking around in here and seeing what changes important here. Okay. There's a 110.26A4 limited access change here. A new provision for, quote, limited access had been added to address equipment. Now, located in a space with limited access. So we're talking about suspended ceilings or in crawl spaces. So previously we had a little bit of an issue of being able to, for equipment that might be above a suspended ceiling and not really meeting full access. And of course the code talked about what access you needed. So basically this is really kind of geared for areas that are going to have limited access, although you're going to have access to the equipment. But we're going to give you some provisions here. It says, look, okay, so there's going to be some limited access. So now those guys that always argued about, well, wait a minute, I can't meet the full requirements of 110.26. This is a limited location. It's above a suspended ceiling. It's allowed to be there, but because of the grid or because of the opening, I just can't get the access. So this is going to apply to equipment above suspended type ceilings. Now it is going to require a minimum space in front of the enclosure itself. Okay, so the working space must be the width of the enclosure, okay, or 30 inches, whichever is greater. Okay, so we're dealing with the width. So you can be able to get full access. You don't have anything in front of the access door. Okay, so we're dealing with the width. Has to be the width of the enclosure itself, the part where you entry into the enclosure, or 30 inches, whichever is greater. Okay, so let's look here. It says equipment installed above, and here's how it's going to seamlessly work in. It says equipment installed above a lay-in ceiling to have access openings not smaller than 22 inches by 22 inches. Crawl space is not smaller than 22 inches by 30 inches. It's going to say, under this limited space, it's going to say the width of the working space is to be the width of the equipment enclosure or a minimum of 30 inches, whichever is greater. So we were already there. The 110.26A1 depth requirements to apply in front of the enclosure height of the working equipment to the height necessary to install the equipment in the limited space. Okay, so the height that we're dealing, we got the width in the enclosure, we deal with that. But the depth of it is going to be required to apply tied to the front of it. So we have to meet the depth requirements in 110.26A1. So that's established. We do, the depth clearance is there. We've already followed that. That's already documented in the table. Now the difference here is the height again. So the width was different and the height is different. Now the height for these limited spaces, it says of the working space to be the height necessary to install the equipment in the limited space. So I have to have obviously enough space to install the equipment. and I got a width requirement, I got a depth requirement, and now as long as I got enough space to install it, which kind of makes common sense. If the piece of equipment, if the height of the equipment is 18 inches and the space is 14 inches, well, obviously this stuff ain't going in there anyway. So makes sense, right? Plus, you also have to remember that a lot of equipment might have clearances. Take a transformer. It needs to be cleared from certain types of distance from certain types of objects, okay? And it's in its manual. It's in its instructions. So that's going to dictate the space that this is installed in. And, of course, transformers that are installed in this hollow space, for example. There's going to be some clearance requirements that might be in the specifications for that transformer. Well, you incorporate that in the necessary space that is required for that equipment anyway, that height. And then that is going to be your limited space, okay? And then it says horizontal ceiling structural members or access panels are permitted in the space, okay? Which basically says, hey, by the way, that ceiling grid arrangement, don't worry about it, okay? All right. We're worried more about the front of the equipment. All right, let's talk about this as it applies to outside. In 110.26E2, we're dealing with outdoors again. In this one, section 110.26E2 has been rewritten into kind of a list format. A new exception to B has been added to address structural overhangs and roof extensions. A lot of times, you can't have anything on the exterior in that space or that dedicated space or that is dedicated for electrical equipment. But the issue was, okay, but what about the natural overhangs or the roof extensions that kind of might be up there a little bit, but it protrudes over into it? Well, we're going to give you some relief from that now because you can't do anything about that. That is structural or an overhang of the building or a roof extension, okay? It's not something that we added in there. It's part of the construction. So basically that gave you that allowance in there. So the exemption, there's an exemption here that's going to permit structural overhangs and roof extensions within this space that otherwise this space would only be dedicated for just electrical equipment. So you get some relief. Okay, that doesn't account now for the sprinkler. It doesn't account for the water spigot. It doesn't account for the drain. It just accounts for overhangs and roof extensions, which makes sense to me. Now, what about the working space provision here? It says, and we're dealing with B. Here's how it's going to read. Okay, we're dealing with working space. Here's how it's going to read here. It says, the working space clearance shall include the zone described in 110.26a. It says, no architectural appurtenance or other equipment shall be located in this zone. Then it's going to say, exception to B is going to say, wait a minute. Structural overhangs or roof extensions shall be permitted in this zone. Okay, so that's kind of what it's going to get into. So make sure you look that up and you kind of get an idea, but don't let don't give them any grief about that part of it, right? So many other things to worry about. All right, let's see here. I can't cover every change, and this is going to be a multi-part series. This is part 1 to these changes. And I'm going to end it right there. We're going to get over and break into chapter 2 and on type items. But I hope you enjoyed this little summary, not all the changes. This is a part 1 of a multi-part series of some of the upcoming changes to the 2017 National Electrical Code. So hopefully that's given you some insight on those things. And we tried to keep it about an hour so that's about where we're at, a little over an hour. So hopefully you got something out of it. Didn't go too detailed, but hopefully I gave you enough. You understand that there's 5 new articles. They're important. They're going to incorporate a lot of this was due to the PV industry and energy storage industry, and they it's constantly evolving. So, and we'll get into some of the ones, but that's just chapter 1. We're going to move on into part 2, and we'll pick up some of the other requirements. So thanks for listening. Hope you enjoy all of our podcasts as usual. Make sure you go watch our webinars. Again, if you have any questions on anything we presented, you want more clarity, you want me to go in more in-depth analysis of any of these, feel free to email me at info, that's I-N-F-O, at masterthenec.com, and I am more than happy to go in more detail. Anyway, Thanks again for joining me. God bless. Until next time, keep safe, do a clean, compliant installation, and hopefully you join us next time here on Master the NEC.